These are the starting components, just so you see them semi-taken apart. You have 2 battery packs. Each one is 3 volts total. This is the positive terminal of the battery pack, the negative, positive, negative. There is a switch, an on-off switch, a motor. In this configuration, we're doing the positive terminal of the motor up here and the negative one here. This will make it spin really fast, but not make the blade fly up into the air. So positive, negative. This is a light. There's no polarity on this light. There's no positive or negative. So it doesn't matter which way you have the light in there. These are them unconnected. So you're going to look at a couple different builds. The first build to go through is powering the motor with either 1 battery pack, which would be 3 volts, or 2 battery packs, which would be 6 volts for students to compare it. So in order to complete the circuit, there's a couple connections you have to make. You have to take this 2-piece and put it across there to go from the battery pack to one end of the switch. And then you have to connect a piece from the switch to one end of the motor. So we're going to take another 2-piece and go to one end of the motor. Now if we're going to power this motor with just 1 battery pack, we're almost complete. To complete the circuit, I'm going to take this black wire, put it on one end of the motor, and put the other end on 1 battery pack. Now the circuit goes through the switch. If you close the switch, current would then flow to the motor and then back to the single battery pack. So this motor would be powered by 3 volts. This fan blade just sits on top of this motor. So the first build the students can hear, see, take notes on what it sounds like having it powered, the motor powered by 3 volts. So if you turn it on, to add power to it, to add the second set of batteries, so we're going to add them in series. The current is adding from the 2. We're going to add up the voltage here. We're going to connect between the 2 battery packs. So now we would have a total of 6 volts by connecting them through here. Now instead, this other end of the motor, we're going to connect down to the bottom of this battery pack. So now both sets of batteries, 4 batteries in total, totaling 6 volts, is powering the motor. And this students can turn it on. They should be able to both hear and feel the wind difference, so taking notes on the sound level difference and the amount of wind difference in having more electrical power, more electrical energy, more voltage to cause motion. A second observation can be seen with light for this. So I'm going to take the blade off the motor. I'm going to disconnect the motor from the circuit here. Put this number 2 back over here. I'm going to disconnect my end connection here. And I'm going to do first, again, 3 volts and then 6 volts, but now just for this light. So for this light, I'm going to take a 3 connection and go from here to here. So now our motor is out of the loop. We're just going from this set of batteries to the switch to the light. Now to test just 3 volts on the light, I'm going to connect from here to here. And now my circuit goes 3 volts through a switch, through the light, and back. So you can have the students observe the light level powered by 3 volts. And then also have them add in 3 more volts by connecting, again, the second battery pack. So you have to connect the 2 battery packs together. And connect this end to this end of the light. And again, right now the motor's not in the circuit. We're just going through both sets of batteries, so we're totaling it at 6 volts through the switch and through the light, and have them observe the difference in the brightness of the light. So different forms of energy, electrical energy, providing either more motion or more light. Now, if you have a voltmeter to use, another fun activity would be to disconnect these pieces and have them double check the voltage they get. So they could connect the terminals of the voltmeter from here to here, and they should read about 3 volts across here. It won't be perfect. Those imperfections are due to resistance in the connections when they're touching it, and batteries aren't magically 1.50000 volts each. They should get about 3 volts across these 2 batteries in series. If they then did a connection across here, and then did the voltmeter from here to here, they should get about 6 volts read from their voltmeter to know they have more voltage, to be a larger potential to drive more motion, more light, more use of that electrical energy in different ways.